Alright, hello students, welcome once again to another section, and this time we have an improper integral over here. So in this case we are to determine the integral, the value of the integral. So we also determine whether it converges and diverges. So if it converges, by all means it will have a value, so then we determine the value, but if it diverges, it will have no value. So let's quickly start. So we have the integral from negative infinity to 0. So over here we have the integral negative infinity 0 1 plus 2x exponent negative s dx. Now this is an improper integral. So now you realize that we have infinity in the limit, so we have to get rid of the infinity. So we get rid of the infinity by introducing a limit to the integral. So let's introduce a limit. So we have 0 to infinity 1 plus 2x exponent negative s ds. So we introduce the limit. So let's say the limit, let's say t is approaching negative infinity. Then we have 0 t here 1 plus 2x exponent negative x dx. So that is what we have. Now what we are going to do next is that we are going to solve this integral. So let's take this. Now if you look at the integral over here, you can see that we have 1 plus 2s and also exponent negative x. So we have to use integration by parts. So by using integration by parts, now the general formula is just given by that, then uv minus the integral of v du. So that is what we have. Now comparing this equation to that, so we have comparing all of this equation to that, realize that your u, in this case your u here is the first one, so the u is just 1 plus 2x. Now in the formula we need the u, so we differentiate u with respect to x. So we have 2, which is equal to, so what is the value of the u? The u is just 2 dx. So we know our u, we know our du. Now what is our dv? So our dv in this case is exponent negative x. So to get our v, what we have to do is that we have to solve this. So integrating this, we have negative exponent negative x here as the value of v. So let's put that into the general formula. So we have it from 0, then we have negative infinity, we have 1 plus 2x here, then exponent negative x dx here being equal to so we are writing this in terms of that. So our so we have this, which is just our u and the v, so the integral of that being equal to our u. So u is just 1 plus 2x here, then we have the v. So we have u dv, our dv is just e exponent that. So we are writing u, so u is just, so v is just negative, so let's put the negative here, then minus the integral of v is just that, so negative v exponent x, then our u, our du is just equal to multiplied by 2 dx. All right, so let's continue here. Now from there we have negative 1 plus 2x here, then exponent negative x. Now negative will give us positive, then we have, so we can also bring the constant 2 out, then we can have that with respect to x. So integrating that, so integrating this, we have 1 plus 2x still, then exponent that plus. So integrating this, we have it from at negative e exponent x plus c. Alright, so from here we have negative 1 over 2x here, e exponent s here plus so minus 2 e exponent s that. So simplifying this, we have negative e exponent that plus 2x here exponent that. So it is minus because negative goes through it. So and that, so we have like terms. So we have this and that as like term, which will give us negative 3 exponent x here minus 2x, then exponent negative x, which is just so let's write it this way: 3 plus 2x here, then negative x here. Alright, so generally we have the integral 1 plus 2x here, e exponent x dx here will be equal to, so remember we didn't have any limit to it, so we have plus c throughout. Now so we add the limit now, so the limit as t is approaching negative infinity, we now have it as 3 plus 2 here negative x, but this time we are going to add so to get rid of the constant over here, so we have it from 0 and then negative infinity. So if that is the case, then we can have 0 and t, right? So having that, and therefore the limit as t is approaching negative infinity, we have 3 plus 2, we have 0 here, then negative 0 here, remember it's negative, then minus bracket negative 3 plus 2t, then we have so negative, we have t here. Alright, so from here we have the limit as t is approaching infinity, we have the total one as negative 3, this goes to 0 and this goes to 0, this goes to 1, so we still have negative 3 here, then minus minus will give us positive, then over here we have 3 plus 2t, so we have 3 plus 2t still being multiplied by negative t here. Now we have the limit as t is approaching negative infinity, so as t approaches negative infinity, we have negative 3. Now the whole of this, so we have 2 negative infinity, then multiplied by e exponent negative infinity, so we have negative 3 plus 2 multiplied by negative infinity, just negative infinity being multiplied by infinity, right? So multiplying all of this, we have our answer being equal to negative infinity. So therefore realize that our we had the integral being equal to negative infinity, so this should tell us that the integral diverges. So the integral diverges in this case. So thank you very much for joining me in this section. We'll meet for another section.